Good evening. The two most popular videos on our channel were the do-it-yourself distributed mode loudspeaker videos. We've had a lot of positive comments, and we've even had some viewers go ahead and duplicate our results, and they've been very pleased with the results. But there is a justifiable criticism. When we did the frequency analysis and we did the music recording, we did it in a room that was not at all acoustically very good. There were a lot of artifacts introduced by the reflections from the walls. And so to eliminate that, what we did is we went ahead and we built this. This is an anechoic chamber, and it's designed to reduce the reflections produced by the speakers and allow us to produce a better recording as well as a better frequency analysis. And it works very well. We're very pleased with this, and we plan to test the speakers in an upcoming video. So let me show you how well this works. Now, one of the problems you have, though, is if you go on Google or you YouTube this, you won't find a lot of instructional videos on how to build an anechoic chamber. And so what we had to do is we had to test the materials and test the layout schedule, but we didn't have an anechoic chamber in which to do that. So we did the next best thing. We took our experiments outside. Come on with me and I'll show you what we did. Okay, so now we're outside and we're going to take our experiments out here to try to reduce some of the reflections that are inherent inside of a room when we test the speakers. So what I've done is I've commandeered one of my son's antenna masts here, and I've placed a hook about 4 meters up into the air to get it far away from the ground. In front of it, I've placed a unidirectional horn-style speaker. And this has a 45-degree half angle, 90-degree total angle of distribution. It's been placed inside of an MDF box, and the box is surrounded by some sound-absorbing material. The purpose of this is to transmit sound toward the test panels that we're going to be evaluating, and at the same time we have a calibrated microphone that's been placed and angled so that it aims at the panels that we're going to be testing. What we'll do to start with is we'll do a frequency analysis that's going to include some of the ambient reflections from the ground, from the vegetation behind us, from the box itself, as well as some bleed that comes through the box despite the insulation that we put around it. So the first step is a frequency analysis that's going to go from 60 hertz to 12,000 hertz, and it's going to establish the baseline that we're going to use to evaluate the other panels. So let's get started. Here we go. The neighbors really like this. Now we'll smooth out the graph a little bit just so it's a little bit easier to see. You'll also see that the cone speaker doesn't have a lot of output below about 300 hertz, and this frequency down here is important for the analysis, but from the manufacturers of some of the materials we have, we know that the performance is going to improve as we change some of the parameters on those materials. But specifically, this is the area that we're going to be comparing because this is where the speaker produces most of its output. So the first panel we're going to test is a piece of gypsum board or drywall, which is the typical material inside of a room that you'd have inside of your house. Okay, now we have a 24-inch by 24-inch by 3/4 inch, or 60 centimeter by 60 centimeter by 2 centimeter piece of gypsum board or drywall. We're going to go ahead and measure that. I'm going to take a look at the comparison. As you can see, there's more reflections as well as a lot more reflection up here in the higher frequencies. These peaks represent bouncing probably from the sides of the speaker, as well as some more reflection to the microphone itself, and maybe even to the building behind us. So now the next thing we're going to do is we're going to go ahead and we're going to test a piece of plywood. Alright, now we've placed the piece of plywood up there, same dimensions as the drywall, 60 by 60 by 2 centimeters. And we'll go ahead and measure it. Smooth this one out, and let's take a look. Now, as you can see, the plywood has a little bit more reflection, but pretty much the same sort of peaks location-wise as the drywall. They're both very hard materials, and they both reflect a fair amount of sound. Now, one of the things that we're going to now study is what kind of performance we get if we place sound-absorbing material. There are two major rigid materials that were candidates for our anechoic chamber. One was the Corning product 703 or 705, which is a resin-bonded glass. And the other material is a Roxul product called soundboard. The advantages of the soundboard over the 703 and 705 material is that it's much more widely available, both online as well as at construction supply houses, hardware stores, big box stores. And because this material is bulky, shipping can represent 50% of the cost of the material. That's one of the advantages of the Roxul product. They both have very similar properties in terms of sound absorption according to the manufacturer's specs. The Corning product, though, because it's a resin-bonded glass, is very irritating. You don't want to breathe the particles that come off of either one of those materials. But the Roxul product does not irritate your skin or your hands. And one of the interesting things that I found is that the Roxul product, which is this stuff down here, cuts very easily. And even though you should wear a mask, I'm not going to do it just with a single cut. It cuts like butter. It's very easy to slice. And the material itself does not contain the same sort of very irritating particles, the glass particles that are in the Dow Corning material. And that's a big advantage because when you're making a lot of cuts with this, which I have done, with bare hands and short sleeves, I've never had any kind of irritation whatsoever. Another interesting thing is Roxul makes what's called soundboard, and they also make a material called comfort board. The comfort board is the stuff that's more easily available in the construction supply houses. But the comfort board 80 and the Roxul soundboard 80 are identical in their acoustic properties, again, according to the manufacturer. The one difference, though, is that the comfort board comes in a slightly different thickness. This is 1.5 inches or about 3.5, 4 centimeters. And the soundboard comes in 1 inch, 2.5 centimeters, or 2 inch, 5 centimeter thicknesses. However, the low frequency response of both of these rigid materials, especially this material, improves as you make it thicker. And it's not good to just take two independent pieces and sit them on top of each other. What you have to do is you have to have something that literally is a solid piece of material that's thicker. Easiest way to do that is to use a spray foam adhesive. This is the same stuff you'd use for poster boards or mounting projects on any kind of a porous material, and it's very easy to use. You just spray a small amount of this on the surface, two surfaces, and wait about 30 seconds. And the material will become tacky, and even though it's very porous, this material will bond to porous materials very well. And if you place them together and you put a little pressure on them, they will act as a single product. And in about 2 minutes, if I were to try to pull this apart, it would actually delaminate before it pulls the bonds apart. And because this is a flexible material, it's rubbery, it doesn't interfere with the sound absorbing properties. So let's go ahead and take a look at what the sound reflection is from a layer of this material. Alright, what we're going to do is we're now going to test a 24 by 24 inch or 60 centimeter by 60 centimeter single layer of the Roxul product. this over. Let's take a look. Now, as you can see, this is the most recent graph, this one right here. And this represents substantially less reflection than the other two products that we were using. In addition, you can see that it reflects substantially less at the higher frequencies than does the drywall, the gypsum board, or the plywood. It's still not down to the control, but as you track this through, you can see that the peaks are substantially less. It's absorbing more. They're still in the same locations though, because basically the panel is probably still reflecting between the speaker and the panel. Now let's go ahead and we're going to test a double layer. Alright, so let's go ahead and measure this. It's a double layer of the same lateral dimensions. Now, as you can see, there's a slight decrease in the reflection and also a change in the pattern of the different frequencies that reflect. Now, the pattern is probably due, the change in the frequency, is probably primarily due to the fact that we're 3 centimeters closer to the speaker, so there's going to be a slightly different frequency where you're going to get reflection. You'll also notice that this most recent graph has a very similar performance to the performance of the single layer, except for the fact that, according to the manufacturer, down below the area where we are unable to scan, the double layer provides a little bit better low frequency response, but at the upper levels it's supposed to be almost identical to the thin material. So if you're going to be using this to try to reduce reflections in the lower frequencies, you might want to spend twice as much and use a double layer. But if you don't want to spend that much and you're primarily interested in the higher frequencies, a single layer should be sufficient to provide decreased reflection. But this still isn't where the baseline is. And so the next step is we're going to add some foam to this material and see what acoustic foam does in terms of reflection. One of the nice things about this spray material is it works so fast as opposed to, say, an epoxy or a glue. Now, this is commercial acoustic foam, and it works very well. However, it's fairly expensive per square foot, and it's one of the reasons why we decided to cut our own, because we were able to cut the costs by about a quarter of what it would have been if we purchased the acoustic foam already cut for us. Alright, now we're going to measure an identical sized panel, but it's covered with the acoustic foam. Smooth it and compare it. Now, as you can see, this green is the same as this green. We've actually dropped below the level of control at the highest frequencies. That control is indicative of probably just the metal pole that's exposed when we do the test with the control in the red. But as you can see, once we get up into this area here, the green shows a lot less peakiness. And although not quite as good up to this point, as which is about 1100 hertz, it begins to be just about as good as the control as it tracks its way down or up in frequency, and then at the very highest frequencies up at around 5.7 kilohertz here. If I scan a little bit farther so you can see a little bit better, you'll see that it remains below the control all the way out to here. These are the Roxol products. These are the hard plywood and gypsum board. And this is the effect of adding the foam. So pretty impressive. Alright, now we're going to go ahead and measure the foam that we cut ourselves. This is out of a higher density foam and at about 25% of the cost of the normal open cell acoustic foam. As you can see, the purple and the last one that we did, the green, perform almost identically over this entire frequency range here. And so you can save a substantial amount of money if you decide to cut your own foam. And in addition, the foam itself can be cut to the dimensions that you want so you don't waste as much. But in any case, the addition of the foam and the use of these sound absorbing panels as opposed to a hard back like wood or drywall provides a substantially improved acoustic reflection performance as opposed to just using, say, foam or just using, say, one of the reasons you build an anechoic chamber is that you don't have as many trucks and cars driving by. In any case, you might be saying, okay, great. Next time I build an anechoic chamber, this is the video I'm going to refer to because I'm going to know what kind of materials and what kind of schedule to use. 3 inches or essentially 3 3/4 centimeter thick Roxol foam glued together and placing on top of that an acoustic foam is an excellent way to build such a chamber. But from a practical point of view, what we've shown you here can be used to build something a lot more useful, and that is sound absorbing panels. If you place strategic panels, they don't have to be full wall size panels within a listening room or a listening environment, you could substantially improve the quality of the sound within your room and not have to spend the kind of money that you'd have to spend in order to coat the entire inside surface with anti-reflection materials. In order to build this very low cost and very convenient, very fast to produce acoustic absorption panel, I'm going to show you a couple of tricks and a couple of techniques that work with the materials and provide you a nice appearing panel as well as a low cost panel that you can throw together in a couple of minutes. So next thing we're going to do is we're going to go inside and I'm going to show you how to do that. Now if you're going to use this technology to try to build some sound absorption panels, we can take advantage of the fact that this material, especially if you obtain it locally, is very inexpensive. This is a half sheet and you can obtain 8 full sheets for about $46 to about $50 in North America. And so this particular sheet represents about $4 worth of material. In order to try to minimize the cost and the weight, what we're going to do is we're going to need to seal the surfaces because despite the fact that this is not irritating when you cut it, nevertheless it could give up some particles that you don't want to breathe. And the back surface, we've got a couple of options. One is we could glue a piece of plywood to the back surface of this and use that as a support to hold it to a wall. We could put some staples or some hooks on there and hang it on a wall. One of the problems there is you're going to be paying for the plywood when it's not really doing anything structurally. And in addition, it adds a substantial amount of weight that you're going to be hanging on your walls. So another trick that you can use is that the epoxy itself that you would use to seal up the surface will lock the fibers down. They won't be able to get out of the back surface. And because this is a fibrous material, when the epoxy soaks into the material, it becomes very hard. It becomes almost like a layer of fiberglass from that 1/2 millimeter or so that the epoxy will soak into the surface. And you will need to use about 1 gram of epoxy for every 5 square centimeters that you want to cover. You're not trying to produce a glassy surface, simply lock the fibers down. Nevertheless, it's a fairly thin surface, and it doesn't leave you with a lot of options on how to hang this if you're going to hang it on your walls. So again, you could use a full-size piece of plywood, but another little trick is you can take advantage of the fact that this material is quite thick. And if we remove some of the material, we can actually place in some hard points that we can use for fastening it and hanging it. So let me show you how I do that. So I selected a piece of wood that I'm going to use as a hard point in the back surface of the panel. And I centered it and marked with a marker the area that I'm going to cut an indentation or a slot. I set up a router with the bit slightly deeper than the depth of the wood so that this will sit inside or below the level of the panel in the back. Then, this will be a little loud. You don't have to be super precise here. Doing this outside is pretty important because you make a bit of a mess. And as I said before, this stuff really doesn't irritate. It's very pleasant compared to some fiberglass materials that will make you itch and you got to wear gloves and more than just a protective mask. Let's see if I get a good fit here. Perfect. Now we'll go inside and we'll glue this up, seal everything in place. Alright, now I've mixed up a batch of epoxy calculated on that same 1 gram per 5 square centimeters. Like I said, we're not trying to build up a glassy surface here. What we're trying to do is seal the fibers. So we'll start spreading the epoxy, and you won't get a satisfying coverage. You won't get it to look all shiny. And avoid the temptation to really load it on in one area because this is very absorbent material and you can soak up the entire quantity in a small surface area. That's the kind of technique you might use if you're coating a non-porous or slightly porous material like wood. You get the epoxy down on the surface and then you depend on the spreader to kind of give you even coverage. Not so here. You have to be a little bit more even-handed in where you put it. Now another little trick is don't be too generous as you're putting the epoxy on in one particular area. You can come back with the dregs of the pot and sort of finish up some areas that you might have been a little skimpy on earlier on, rather than getting 3/4 of the way through the surface and then you got to mix up more epoxy because you were too generous. And you'll notice that the surface becomes generally darker like this as it soaks in. And remember, we're not building an airplane here. We're just sealing fibers, so completely homogeneous coverage is not really that important. No one's going to see this either, unless you want to show off your panels. Now once you've gotten this coverage on here, you have the option obviously of putting a piece of plywood down. You do the same thing because you want it to stick to the plywood. And in that case, it's generally a good idea to put a little coat on your plywood as well as on this material here, so that you make sure that the fibrous absorbing qualities of this material don't starve the joint and you have some material or some of the epoxy in the wood fibers as well. And we're going to do the same thing with our insert, but you need to make up just a little bit more if you are going to soak a large quantity of wood. But as you can see, this goes pretty fast. And this I would consider to be a half panel. I would say typically, if you're going to be making reflective panels, or absorbing panels I should say, using the full sheet might be advantageous because it's a little bit less cutting. And the method that you're going to use to place the absorbing panels is kind of a neat little trick. What you'll do is, let's say you have a listening room and you want to have these panels maximize their benefit. What you do is you get a friend with a little bit of marking tape, something like painter's tape, and you have him stand against the wall with a mirror and sit in your favorite spot. And when you do so, have him slide the mirror along the surface of the wall until in your favorite spot you can see a reflection of one of your speakers. Have him put a mark there. That's going to be the location of a primary reflection of sound from that speaker to your favorite listening spot. You'll do it on both side walls, but don't forget to look behind yourself as well at the back wall. Then have him repeat it so that you can see the other speaker if you've got a simple stereo system. To be more thorough, you might also pick a couple of locations where you might have other people who are in the room with you and also mark those locations as well. You may end up with about 8 pieces of tape on the inner surface on the walls of your listening room. Putting absorbing panels on those surfaces at those locations will take care of most of the primary reflections of sound from your speakers. And it's a heck of a lot less expensive than treating all of your walls with an acoustic absorbing material. The ceiling, you can do the same thing, although an acoustic ceiling is certainly a good choice, although they don't necessarily look very attractive. And a floor that has a carpet on it is going to be better than a hardwood floor. It's best that you put the carpet in front of you, because that's where the sound is going to be bouncing off the floor. But it's the walls that we're primarily thinking about with this material. That's the area that we're really trying to block most of the sound. Because even though there are tertiary, secondary and tertiary reflections that will happen as the sound bounces back and forth between the walls, it loses energy. And so if you can take care of the primary reflections first, you're going to gain the maximum benefit from the least amount of expense and effort in producing these panels. Now I've made up a little extra material, epoxy. I'm done. You really don't have to put any more than this on here, as long as you get your edges. And now the fibers are not going to be able to come out of the back surface. We've also made the surface enormously more rigid. It's almost like it's a piece of garolite now. And the panel will be very difficult to flex, meaning it's got the kind of stiffness that you might want to have if you're hanging it from a single point, so that it's not bending and flexing in your hands. And that comes from the fact that we've actually built a composite structure here. And now just before I finish, we'll put a small coat on the wood itself, and this is to ensure a good bond with the wood that is going to be inserted into the slot we formed. And using the panel as a nice place to absorb some of that extra epoxy is kind of a neat little trick. And you just fit this into that place, push it down so it's nice and flush. And then the last step will be to ensure that this rather rough surface doesn't lay against your fine walls. And so while you still have some wet epoxy there, take some of these small felt pads and simply place them into the epoxy near the corners of your panel. They'll end up being bonded just as well as the wood is. And that way, when it sits against the wall, you don't have this hard surface that's sitting against your wall. You have these nice soft felt pads. This will work with a 2x2 or 60 by 60 centimeter, or the full sheet, which would be 60 by 120 centimeters. Now, you've sealed the back, but you still have exposed sides, and obviously you have an exposed front. We don't want to seal that, because if we do, it'll become hard and no longer reflective, but we don't want the material to get out. So we need to do something to the front surface in order to improve the absorbing qualities. And what that means is we're going to put these on the front surface. So what we need to do is we need to spray some of that spray adhesive on this material as well as the other surface. And to do that, it's kind of nice to do that outside. I've marked the panel where I'm going to be putting the adhesive. One of the things you should do is don't follow the manufacturer's recommendations on this stuff. Put it on thick. This stuff absorbs the glue pretty effectively, and if you're not generous, after a day or two you'll get some of the acoustic foam to drop off. So don't be chintzy here. The stuff isn't that expensive. Now what we're also going to do is we're going to spray the sides. Now I'll show you and explain why we're doing the sides in just a second. But as you see, I've marked where I'm going to be putting these acoustic panels. And the reason for doing that is I want a little bit of overhang on the edges. We don't want any kind of fibers to be released from the edges, but we also don't want to use a hard epoxy or something that's going to cause the edges to become firm and reduce the sound absorption qualities. And so rather than seal this up in a wood frame, as you'll see some acoustic panels are manufactured, what we're going to do is we're going to put some acoustic foam on the edges as well. And this fits together very nicely. Once that's done, then what we'll do is put a little spray of this on some additional acoustic foam. And I'm doing this in a bit of a hurry, but you can get the alignment pretty good here. Little side piece over here, similarly lined up. And if you get continuous strips, that can save a fair amount of time. But you can see basically what I'm achieving here is a foam pad. This stuff costs about $8 for this material right here if you buy it in reasonable quantity. $10 if you're buying, say, just a single pack of 4. The panel underneath costs about $4. So we're talking about $12 plus the glue. So for about $14 or $15 you could build a panel like this, and for about $30 you could build a panel twice as good as this, or twice as large. The nice thing about this kind of an acoustic panel is it absorbs from all the surfaces. You can use different types of material. I decided to use a linear corrugation here. You could use smooth foam if you wanted to. The differences between the corrugation and the smooth for this small area would be relatively low. You could even use some of the same acoustic foam, just make sure that you have enough overhang to hide the depth of the foam so it doesn't seem to stick out too much. But once this is done, this can then be hung on a wall, and it would have a reasonably nice appearance from the edges. And at the same time, it's very light, so you could hang this on a relatively weak surface. It doesn't add a lot of weight, but as we saw before, it does add a lot of sound absorbing performance. So even if you're not going to build a anechoic chamber, you can use this kind of technology, and for probably less than $100 you could put a number of these panels in a listening room, and you'd be very impressed with the improvement in the sound quality. In the next video, what we're going to do is we're going to go back to the anechoic chamber, and we're going to go ahead and we're going to test our speaker panels and some commercial speakers to get a better idea of how they perform when we don't have the reflections and the aberrations caused by the large hard surfaces in the room that we had originally demonstrated those speakers within. So I want to thank you very much for watching. Hopefully this is useful as well as interesting. Again, please subscribe. It really does help us out. You have a wonderful afternoon. See you soon.